Hello everyone. Today we are starting with a new topic, DFA, Deterministic Finite Automata. First we will see the types of finite automata. In finite automata there are two categories: finite automata with final state and no output, finite automata without final state and output. In finite automata with final state with no output means at the last we will get the state, not the output, in which there are two types: NFA, which is called as a non-deterministic finite automata, and DFA, which is deterministic finite automata. In the category NFA, FA without final state and with output, there are two types: Moore machine and Mealy machine. Always remember, when there is no final state and there is an output, there the machine comes, Moore machine and Mealy machine. So today we will learn a basic concepts of DFA, deterministic finite automata. What is deterministic finite automata? DFA consists of finite set of states in which one state is called as a starting state and there can be many final states. In DFA, from each state on each input symbol there is exactly one transition. Let's see what it tells. Means if there is a Q0 state, consider and it is receiving input symbol 0, 1. If it receives 0, I am sending it to Q1. If it receives 1, I am saying it is on the same state. This is a DFA. Means on receiving 0, it is making only one transition, means going from Q0 to Q1. On receiving 1, it is only on one transition. It is going to same state only, that's no issue. But a transition is only 1. Means on each input symbol there is exactly one transition. This is DFA. Now how NFA differs? See, for the same question there can be a condition like this: Q0, on 0 it is going to Q1, but on 0, 1 means if Q0 receives 0, it can go in own state or it can change the state. Means for the each input symbol, means for the input symbol 0, it is making transition to Q1 as well as Q0 also. That's why it is non-deterministic. It is an example of NFA. DFA in the mathematical equation can be represented as M equals to Q in which where Q equals to finite set of states. Like if I have it in this DFA, Q0 and Q1 are two states, means Q will be shown as Q0, Q1. It is summation, it is here called as, not this symbol is called as input, it is called as a delta, is called as a transition function, that is Q into input symbol is giving you state only. Q naught is start state and F is finite set of final states. This is a mathematical equation. I repeat once again, what is DFA? DFA consists of finite set of states. One state is called as a starting state and there can be many final states. In DFA, from each state on each input symbol there is exactly one transition, only one transition. Then only it is called as DFA. Sorry. To understand the DFA easily, let's take some examples. Our first question is string ending with 0 1 over the input alphabet 0, 1. So in this, if we give input like null means epsilon, so it will not accept. 1, no, it will not accept. 0 1, yes, it will accept because it is a string but ending with 0 1. 0 0, no, it will not accept. 1 1, it will also not accept. 1 0 1, yes, it will accept because it can start with 0 or 1 but it is ending with 0 1. So let's try to draw the transition diagram. I am taking a starting state q0. It is a starting state. I will check if it is ending with 0 or 1. Means if it is ending with 0, I am making a transition to a new state q1. Okay, now see, if it start with 0, it will to q1. But if it receives 1, I want to keep this in on the same state. Means if for epsilon it is on the same state q0, means it is not a final state. For receiving 1 as a string, it will on the same state. If it receives 0, I am going to q1. Now if q1 receives 1, I will it pass to q2 and this will be a final state. Now see, for epsilon it is on same state, non-final state. For 1 in a non-final state, but 0 1, it is receiving 0 to q1 and q1 receives 1, it is going to q2. Means yes, it is ending with 0 1 and our final state is q2 and it is going to q2 only. Means it is accepting. Now see, a string like, see, if I apply this 1 0 1 1 0 1, yes, it is accepting. But in this I have make a transition of only 1. Where is the 0 transition? Means if 0 receives, if it receives 0, I will transit to same state. For example, 1 0 0 1. If it receives 1 in the same state, if it receives 0 in a q1, if it receives again 0 in q1 only, I will make a transition, and again 1, it will go to q2. Means ending with 0 1, it is coming, correct? So for this state we got the 0 and 1 transitions. If the string contains like this 1 0 0 1 0 1 0, something like this, means it is going for 0 1, yes, it is came and it's going to come to q2, but the string is containing further alphabets 0 and 1s. If it receives 0, then what I will do, I will make a transition to same state only, and if it receives 1, I will make transition to q0. Now see, if I take this example 1 0 0 1 0 1 0 1, means ending with 0 1. Let's try this. It must accept 1 on a same q0 going to q1. It is again getting 0 on the same state, 1 coming to q2, but the string is remaining. That's why if it receives 0, going to q1, yes, it is receiving 1 going to q2. Again it is receiving 0, q1, receiving 1, going to q2. Means at last we are getting the final state, means it is accepting. So this is our first example. Our second example, string containing exactly one A. Now see, what can be the strings? Epsilon means null, A, B, AB, BA, ABB, AAP must contain exactly one A, means one A must be there in the string. It is null, so it is rejecting. Yes, this will accept, this will also reject. Yes, there is be no problem, but there is only one A, it will accept, it will also accept, it will also accept, but this will not accept, it will reject it, because A, there are two A's, but I want exactly one A, that's why it will reject. Another example, BAB, yes, it will also accept, because there is only one A. There can be many B's, no issue, but it must contain only one A, then only that string will be accepted. So let's make transition diagram. Q0, I am taking a starting state. If it receives a I am saying to go to Q1. See, I want only one A, I am making it is the final state. But if it receives B, I say go on the same state only, means make transition on the same state. Now see, this state will also get A and B, means we can get A or B. If it receives B, no issue, we will say you stay on the final state only. But if it receives A, means there is more than one A, so then we have to reject it. Then we are making a transition on another non-final state Q2. Then for example, see, for null, it is on the Q0, means non-final state, reject. For A, it is going to Q1, accept. For B on a Q0, reject. AB, Q0 will get A, Q1 will be on the same state, means final state, it will accept. For same this also B, A, accept. A, B, B, accept. But for this C, A, B, A, it will, means there are two A's, means we have got two A, or many, or we can get many also, but we want only one A, then only we can accept that string. I got 2A, means I have to reject. Then I will make transition of B on this only, means I will not move from this state. Now see, A, B, Q2 is a non-final state, means we will reject it. Now it can get again a also. I am making the same A on the same state only, transition. I am making the transition of A on the same state only. Now see, for example, if I receive A, B, this will reject, because there are three A's. Now see, A, B, A. It came to Q2, but there is a BA remaining, that's why I make these transitions. BA means it is on the same state only, because we have got more than one A, then it will come in Q2. That's why it will get rejected. And this is our transition diagram. Let's see this example. B, A, B. It is on the Q1 final state, means it will get accepted. Okay, now let's see our third example. The question is string with even number of zeros. Means we want the strings which will contain even number of zeros. Now even number of zeros, even numbers are 0, 2, 4, 6, 8, 10 and all. Means it can contain 0 zeros, 2 zeros, 4 zeros, 6 zeros, 8 or 10 or many more even number of zeros. Okay, let's see some examples. This null string, yes, it contains 0 zeros, means it is satisfying. 0, 0, yes, it will also accept. 0, 0, 1, it will also accept. Now see, 1, 1, will it accept? Now see, it contains 0 zeros, means 0 zeros, even number of zeros, it will also get accept. 1, 1, 0, will it accept? No, it will not accept, because it contains 1 0, that is odd time 0. That's why it will not get accepted. So let's start making our transition diagram. Okay, our q0, this is our starting state. I will make this as a final state too, because see, if we get a null string, it will on the q0 only, and q0 must be accepted because null string also contains even times 0, means 0 times 0, but 0 is also an even number. That's why I am making this as a final state. If it receives 1 only, I will make a transition on the same state. If it receives 0, I will make transition on a different state, that is q1. Now see, for example, if I get example 1 0 or 0 1, let's see this. It contains 1 times 0, means it must be rejected. Now see, 1 0, it is coming to q1, which is non-final state, means it will get rejected. Same for this 0. If it is 1, I am making the same transition here, 1 only. 0 1, therefore this will also get rejected. Now see, if it is getting only 1 0, I will say you are not an even times 0, means I will pass it to q1. If q1 gets again a 0, means there can be a chance of odd even times, I will pass it to q0. Now let's see this 0 0, yes it is accepting. This 0 0 1, yes it is accepting. 1 1 1 1, yes it is accepting. 1 1 0 1 1 0, yes it is rejecting, means our this is our transition diagram. It is correct because since we want even time 0, that's why we are making transitions of 0 on different states and transition of 1s on the same states.